Hey y'all, I want to show you how to solve equations in this video. So basically what an equation is it's basically a math problem, right? But it's going to have letters in it, like alphabets, and it's going to have numbers in it, and it's going to have an equal sign, right? It's going to have all three of these guys. And what we're doing is trying to balance it. And by balance it, I'm talking about the equal sign. We got to make sure everything is cool on both sides, right? Everything is equal. And let's see, what does that mean, right? Like, what do you mean equal? Because how do you balance like the letter A? You know what I mean? So I'm going to show you. I'm going to walk you through it. Because, like, I mean, the idea is kind of vague to say to balance something. And then you're given something that's really, like, I guess, abstract. Let's try to do this right here. I'm going to use this example. Okay, so we're going to balance this. And when I mean balance, this is going to be like that little point that we like start throwing things around. And what do we throw around? Well, your math problem right here, this equation, is going to have directions attached. So usually it's going to say something like solve for x, right? Basically, when it says solve for x, basically it's saying isolate x. So what we're going to do is we're going to take this 4, throw it over here. We're going to take this 3 and throw it over here. So all we're going to be left with is x equals and a bunch of stuff right here. That's what it's going to look like. But it's like, how do I know how to move things over? I can't just throw them over, right? It can't be that easy. So yeah, there's a cheat code, right? So here's the cheat code. If the equation is if it's giving you a plus sign, which it is, we have a plus 4 right here. If it's giving a plus, you're going to do subtraction, right? Let's do that. If it's giving that, you're going to do a negative. If it's giving you a negative, you're going to do a plus. If it's giving you multiplication, you're going to do division. And if it's giving you division or a fraction, both of those. If it's giving you this and that, which is the same thing, it's just set up differently, right? If it's giving you both of these, you're going to do multiplication. This is your cheat code. You need it. Cheat code. We need this cheat code. Without this cheat code, you're not going to be able to do this very well. And this is like straight up for all of these equations. Every time you throw things over, it's called algebraic manipulation. That's like the term they use. When you have to take all these extra little things and then throw it all on one side of that equal sign and keep x by itself, that's called algebraic manipulation, and you've got to use this cheat code. So let's go ahead and start. So we have to get rid of everything and keep x by itself. So let's start with 4. You could start with anything, but you want to start with 4. It's just easier. You want to start with stuff that's not like touching x, and then we mess with x at the very end. So I have a plus 4. So if I look at my cheat code, it's giving me a plus. So what I'm going to do is I'm going to subtract. Whatever I do to one side, I gotta do to the other side. The whole point of balancing is messing with both sides of the scale. You got to think of it like a balance scale, like a little balance beam like this, right? So both sides gotta be even. You gotta mess with both sides. That's a really bad drawing of, I don't even know. All right, sweet. So let's go ahead and try to doing this over here. Okay, so cool. So 4 minus 4 is 0, right? 19 minus 4, that gives me 15. If you have a calculator, it just goes by faster. So unless you have to do all of it by hand. So now I'm going to bring all this stuff down. I'm going to bring down this 3. I have 3x now. I'm going to leave the 0 just hanging out by himself. We don't need him anymore. I'm going to bring down my equal sign. And I'm going to bring down this 15. Cool, sweet. Do you see how it's kind of gotten smaller? We got rid of that 4 completely. Now I have to get rid of that 3 because x has to be by itself because it says solve for x. It never said solve for 3x. It said solve for x. So what do? Well, it looks like it's being multiplied, right? These two things touching each other. So what's my cheat code? It's giving me multiplication. I got to divide. So let's see. How do I do that? Well, let's just divide by 3. And whatever you do to the left side, you gotta mimic that on the right side. And whatever you do to the right side, you gotta mimic it on the left side, right? And the sides are right here. This equal sign, right? Okay, cool. Now what do I do? Well, let's see. 3 divided by 3, that's basically 1, right? So that's an x. Let's bring that down because there's an invisible 1 right here, but we don't need that, so we're just going to keep it as x. Equals. Well, how many times does 3 go into 15? It goes in 5 times. So I have a 5 left. This is my final answer. How do I know it's my final answer? Because like I basically don't even know what I did. Like I just kind of had to just like follow this cheat code. I'm not even sure what's up. Well, we can go ahead and put it back into the, let's get rid of this. We can put it back in. We can put our answer back into the actual question and test it. So I had 3x plus 4 equals 19. That's what they gave me right here. I just moved it way over here. So let's go ahead and rewrite it. Because it's telling me x equals 5. So I know what x is. It's 5. So I'm going to replace it, right? So what is that? This is a 15, right? 3 times 5 is 15, plus 4 plus 19. Well, 15 plus 4 is 19. And this is already 19, right? So 19 equals 19. We balanced it. This was the whole point. We had to make sure that both sides were chill. So basically, I moved this x out of the way and I replaced it with a 5. So this is 19, this is 19, it's chill, this guy's cool, the answer is 5. You don't got to mess with that. That's just to test it. This is a testing. Testing. We're just testing to see if we balanced it correctly. And we did. So our final answer is x equals 5 for this problem. And we use this cheat code. This is something you'll need. And we're going to mess with this throughout the entire video because I have a bunch of examples if you want to stick around. Let's try some of the examples. This is a good one. Here's a fraction thing that we were talking about earlier for our cheat code. So, I mean, we can write the cheat code down if you want. Okay, giving, and then we're going to do. So if we have a plus, we're doing minus. If we have a minus, we're doing a plus. It's kind of like opposites, right? If you have a multiplication, you're going to do division. And if you have a division or a fraction, you're going to multiply, right? That's our cheat code. We need it. Cool. So let's see. I have solve for x, which means we're going to have this guy by itself and everything else is thrown to the other side. So, of course, we're going to mess with whatever doesn't have x touching out, which is this right here. You could technically do anything. You can start here, you can do something here, but you want to keep it easy. And the way to know what's easy is you just got to do a handful of problems to kind of check it out. That's really the only way, because your easy might be different than my easy. So let's see, I have a minus 4, so that means I have to do plus 4. Whatever I do to one side, I got to do to the other. Maybe I shouldn't have that little equal sign there right now. Right? This is 0. And then I'm subtracting. So let's see. This one's supposed to be an add. Okay, we're adding because we have a negative, so we're doing the opposite. So we're adding. So this gives me a 6. So I'm going to bring this down. I'm going to bring down my equal sign, and I'm going to bring down my 6, which gives me x over 5 equals 6. We got rid of that 4 because it turned into a 0. So that's my next thing I have. So what do I do now? Because that x is weird. It's just kind of like in this whole thing. I don't know how to get rid of it. Well, it looks like it's division, right? It's technically division. It's fractions, right? A fraction is a division. So what do? I multiply. How do I multiply? Well, you're going to do one of these right here, right? If the x was in the bottom, let's pretend the x was like, it looked like this, right, equals 6. Let's just assume it was like that. Well, how do I do the whole getting rid of the x thing now? Well, you would do one of these, right? Do you see how, because these cross out, just like this, these cross out. Do you see how that goes, the opposite? It takes a second to see it. But we're not messing with that. That's just kind of visual. So what do I have left? Well, I got to do it over here too, right? Anything you do there, we got to do right there. So what does that give me? Well, it gives me an x over here by itself, and then it gives me 6 times 5 over 1. When you see like the little 1 in the bottom, you don't have to keep it. You can get rid of it. So it looks like this. 6 times 5. You could keep the 1 if you wanted. All whole numbers, like a 2, a 7, a 38, they all have this little invisible 1 underneath. So you can get rid of it. So now what do I do? Well, it looks like I have x equals 6 times 5. Everything is already isolated. So all I have to do is just multiply these, which is 30. 6 times 5 is 30. This is my final answer. I'm done with this problem. However, I have to make sure that it's correct, so I have to test it. And we test it just like we did earlier, right? Where you take the original problem, and whatever your answer was, you just throw it in there. So we had a 30 for x, so we're doing 30 over 5 minus 4 equals 2. Right? So what does that give me? How many times does 5 go into 30? It goes in 6 times. So I have 6 minus 4 equals 2. Right? That's what this became. I got rid of the fraction. What about 6 minus 4? What does that give me? It gives me 2. It looks like it's balanced, right? The balanced number, when you test it, it's going to be some random number. It's not going to be the same as our answer, right? So this is a testing thing. This 2 equals 2, you don't necessarily need it. It's just to make sure that you're doing your work right, right? So, but this right here, this x equals 30 is the final answer, and this is what your teacher wants. When it says solve for x, this is what they're looking for. This is just you testing to make sure you're chill, you're doing everything correctly. Let's do more problems. Here's the thing with these. They're going to get a little bit tougher as we go down, okay? Like it gets a little bit more hard. There's more steps involved. So that's why there's a bunch of fractions already, because like I know they're kind of hard to mess with. So let's go ahead and try doing this problem. And we're doing the opposite of everything, right? So if it's a plus, we're doing minus. If it's a minus, we're doing plus. If it's multiplication, we're doing division. If it's division or a fraction, let's do frac. We're doing multiplication, right? Giving, doing, right? Cool, sweet. So I have a negative 6, so I'm doing plus 6 here. I got to do the same thing on the other side of this balance beam thing we're doing here. What does that give me? This gives me a 0, but this gives me 18. So let's bring everything down. So it's going to be 3 over 5x equals 18, because I got rid of that 6. I mean, we're making really good progress. Everything looks so nice and neat because everything's getting subtracted out. But what do I do now? Because I have to get rid of that fraction. Well, let's see. I have to do whatever I do to one side, I got to do to the other, right? So we have to get rid of this fraction. So what we're going to do is we're going to do a 5 over 3. I'm going to multiply by 5 over 3. That way we can get rid of the entire thing. But I got to do it over here too, 5 over 3. Right? So what does that leave me with? Because that's gone, that's gone. I have x equals 18 times 5 over 3. And what's the rule with anytime you're messing with a fraction against a whole number, you put that invisible 1 underneath, just to make it easier for you. You don't have to do it, but it's just a good visual. And now we're going to multiply across, right? So let's see, that's going to be 90. and this is going to be, 18 times 5 is 90, and then 1 times 3 is 3. And what does that give me? How many times does 3 go into 90? It goes in 30 times. So it gives me x equals 30. It looks like we have the same answer again, right? So this is our answer, but how do we know it's our answer? Well, we're balancing stuff, right? So we can do our own bookkeeping and testing. We don't have to just turn it in and rely on the teacher to tell us. We can do our own work. I mean, I guess you could skip this step and just submit it. I mean, it's not necessary. It's not mandatory. So we're going to replace that x with what we came up with, which is 30, right? So that's what it looks like. That's what we're solving for. But we have to kind of break it down in a different way. So right here, we're going to have to put that invisible 1 underneath it, right? So 3 times 30, we're going to have to do, which is 90. And then we got that 5 times 1 minus 6 equals 12. And, you know, it gets elaborate because now I have to, oh, I guess it doesn't. We don't have to do that. We don't have to find the greatest common denominator because 5 goes into 90 18, I think 18 times. 18 times. 12, yeah, right? So it becomes 18. This whole thing becomes 18 minus 6 equals 12. We got rid of that fraction. 18 minus 6 is 12, right? And I just brought this down. So it's 12 equals 12. It's balanced. That was the whole point. Basically, we have to guess what number is supposed to be x. And we do that by throwing things on one side of the equal sign, on the other side of the equal sign, by doing the opposite, right? This cheat code here, the opposite of the operator. The operator is plus, minus, multiply, divide. We do the opposite, and we're basically guessing, but mathematically, what x is supposed to be. And then I go in and test it to make sure I did it legit. And yeah, we straight up did it legit. So it's 12 equals 12. So it's totally balanced. But the answer is actually this. When it says solve for x, it's 30. That's the answer. This is just us testing to make sure. We don't need 12 equals 12. That's just for our own like reference. Sweet. Okay, let's do another problem. I have 5x equals 2x minus 6. And we're solving for x. This one's interesting. Let me rewrite it. 5x equals 2x minus 6. Well, this one's pretty different because we have x twice. So what do I do now? Because I haven't had that problem yet. I don't know what to do. Well, we do exactly what we've been doing, right? We just put all the letters together. We put all the numbers together. That's what we've been doing. You know, when we isolated x, all the numbers were put on one side, all the alphabets were put on the other side. So we're just going to do the same thing. So that means all the x's are going to hang out together. So how do I do that? Well, I have 2x, so I'm going to subtract it. I'm going to subtract it from this side. Here's our equal sign. Here's our boundary. What does it give me? Well, that gives me 0. And then 5 minus 2 gives me 3x. So let's bring it all down. I have, let's do a different symbol. Let's do the arrow. Let's bring it all down. I have 3x. I'm going to leave that 0 as it is up there. I don't need him. Negative 6. Right? I brought down my equal sign. I brought down my negative 6. Cool, perfect. What do I do now? Well, I just have one x now. I do exactly what I've been doing. I'm going to divide this 3. Bam, bam. X equals, let's see, how many times does 3 go into 6? Well, firstly, let's see, can it go in? Yeah, probably. Let's try. It looks like it goes in twice. But there's a negative sign. I got to make sure I put that in there. So my answer is negative, because I brought that negative down, 2. This is my final answer. solving for x. X is -2. And maybe I'm confident. Maybe I know for a fact that's the answer and I can move on to the next problem because I don't need to mess with it anymore. But let's go ahead and do our testing. So it was 5 mystery number equals 2 mystery number minus 6. We decided our mystery number is -2. -2, right? So that gives me -10 equals -4 minus 6. Well, -4 minus 6 is -10. And then I bring this down because I can't do anything else with it except bring it down. And it looks like, yeah, it's balanced. -10, -10 on both sides. Cool, sweet. So now I know, this is my testing, my bookkeeping. Now I know that this is right. I can turn this answer in of -2 as my final answer. Let's try another problem. Let's try this one here. Oh, okay, it's kind of similar. Let's rewrite it because this, I feel like it's kind of like a lot of stuff and I think it helps to rewrite it. 4x plus 5. Okay, it's kind of similar to what we just did, where there's multiple x's, and it's telling me to solve for x. So what do? I'm going to put all the x's together. I'm going to put all the non-x's, they're called constants, together. A constant is just when a number is naked hanging out by itself. Like these two are constants. So let's try doing, let's do -4 on this side and -4 on this side. And by the way, you could even do -6 here and -6 here. It doesn't really matter. I'm just picking a random one. You're going to get the same answer every single time, as long as you follow the cheat code, right, that we had. So this gives me a 0. This gives me a 2x, right? 6 minus 4 is 2, and then we bring that x down. Okay, so what does all this give me? It gives me 6x plus 3 equals 5, because I got rid of that 4. Well, now it's looking a little bit more traditional, what we've been doing in the beginning of the video. So let's go ahead and move that 3 over, because I feel like that's a legit thing to do. That gives me 0. And when that gives me a 2, it gives me a positive 2. 5 minus 3 is 2. So let's bring this down. I have 6x equals 2. Oh, this is a 2 right here. We messed up, right? Because we're supposed to bring this 2 down. Whoopsies. Okay. This is a 2, right? Okay, because this is what I'm bringing down. And then I brought him down again. So I have 2x, kind of running out of room here. I have 2x equals 2. I got to get x by itself, so I have to divide by 2. It's kind of getting weird now. Well, 2 divided by 2 is 1. So I have x here. But what about 2 divided by 2 here? What does that give me? Well, it also gives me a 1. It's a positive 1 in this case. This is, in theory, my final answer, right? Now, it could be my final answer. I could have done the math wrong. Who knows? But let's go ahead and test it. Right now, I'm putting it in a box, telling myself that this is legit the final answer. But I gotta make sure. So let's do 6 mystery plus 3 equals 4 times mystery number plus 5. Right? That's the this is the white font. I rewrote it. And I'm going to put that x number in there, which I came up with as 1. So let's solve this. This is a 7 plus 3 equals, what is 4 times 1? It's 4. This is a 6. I don't know why I'm making all these mistakes. I guess I'm fatigued. I haven't eaten anything today. 6 plus 5. Great. Let's see. This is a 9. 6 plus 3. And then 4 plus 5 is also a 9. Cool, sweet. It looks like it's balanced, right? We're going to end up with some random number here, but they're going to be balanced. They have to be balanced. And it looks like it's legit balanced. So my final answer is x equals 1. Hooray, we're doing great. Okay, let's try another problem. Let's see. This one is solving for y this time. So it wants us to do y, is that a plus sign? Plus 8 equals 19. Sweet, okay. Except this time we're doing y. What's the difference between x and y? Nothing. They just want us to solve for y. They just switched it up on us. But everything else is exactly the same. Y and x don't hold any kind of special thing. It's just a random number they picked. They could have asked us to solve for solve for a letter star and given us a star symbol. So let's see. What am I going to do? I'm going to mess with the constants first, right? So let's do -8, and we'll do -8. Right, that gives me a 0. And then this one gives me an 11. So then I have y equals 11. Well, that was pretty fast. Hooray. We're thinking this is the answer. Let's test it. So I have mystery. What's that, a plus sign? Plus 8 equals 19. Okay, cool. Let's see. And we were given 11. So let's see. 11 plus 8 gives me 19. And I'm going to bring down this 19. Yeah, it looks legit. It looks like we did it right. So yeah, so our final answer is y equals 11. Great, wonderful. Well, let's do another one. I think I have like 3 more, and then we're chill. Let's see, this one is pretty elaborate. It looks like it's solving for p this time. So I have 2 equals p plus 5 over -2. Okay, wow, it's a pretty big fraction going on here. We haven't done one of these yet. Let's see. What do I want to do first? What should we do? Well, we got to get rid of we got to break down these little things attached to the p. So let's do the denominator first, the bottom number right here. Right? There's a few ways of doing this. We're just going to do a quick basic way that I think might be helpful. There might be a better way to do it. And yeah, I mean, I guess comment down below if you have a different method. So we're going to do -2 over 1. Right, that's what the method I'm going to implement here. -2 over 1, right? So that gets rid of that -2, and it brings it over to the other side, which leaves me with -4, right? Because I multiplied these two together. -4 equals p plus 5. Nice, nice, very smooth. Now we have a whole line. It's like linear now. What do I do now? Because I want to get that p by itself. So in order to get the p by itself, I'm going to do -5. -5. What does that give me? Well, 5 minus 5 is 0. And then -4 minus 5 gives me -9. And what does that give me? It gives me -9 equals p. It looks like it's kind of backwards, but the answer is p equals -9, right? So p equals -9. Oops, -9. These are both the same exact thing. It's just flipped. So sometimes it's going to look weird, but they're the same thing. So I'm going to assume that's the answer. Let's go ahead and test it out. Let's see. I have that mystery number, the plus sign with the 5, and then I got that -2 up in there. Cool, sweet. Let's see. I'm going to put -9 in here. And let's see. This right here, I'm going to do 2 equals -9 plus 5 is -4 over -2. -4 divided by -2. How many times does 2 go into 4? It goes in twice. So I have 2 equals, well, I know the answer is 2, but what do I put here? Because I have these 2 negative signs. Well, 2 negatives make a positive, right? So it becomes 2 equals 2. So it looks legit. It looks like I did it right. It's balanced. It's the same exact number, and it's also the same exact sign, because it has to be either plus plus or it has to be minus minus. That's the only way it has to be legit, perfect, down the center equal. If one is plus and like minus or something like that, we did it wrong. It's straight up the wrong answer. And if this isn't balanced, if this is not balanced, that means this guy is wrong. We have to start the whole problem over again because we messed up somewhere, right? So we did it right. So that means this is legit the final answer. It's P equals -9 because we did actually get the right sign. We got close to getting it wrong because, you know, that this negative stuff could have gone any direction. So we got it right. Sweet. Let's move on to another problem. This one looks pretty tough. Okay, let's see. So we have a lot of stuff going on, and it wants us to solve for b. And if you look closely, there's two b's. What's up? Why? Okay. And there's parentheses, so there's a lot of stuff going on with this one. So here's what we're going to do. We're going to distribute this 4 into this, right? How do I know to do that? Well, PIMDOS. We can't get away from PIMDOS. He's our little puppy. Everywhere we go in the house, he follows us. Even to the bathroom, even to the kitchen, even when we try to get dressed and leave. So PIMDOS is going to be with you for the rest of your math life. Anytime you do math, PIMDOS is going to be hanging around until you literally die. Literally until you die, PIMDOS is going to stick around. So we got to get acclimated to it. So our puppy is telling us that we got to distribute 4 into all of this because parenthesis, right? Cool. So let's go ahead and do that. So I have 48 equals 4b minus 16b. Where did I get 16? I multiplied 4 times 4. And then I'm going to multiply 4 times 3, which gives me 12. Right? I got to keep that b, and then 4 is a constant, 3 is a constant, because they're naked numbers just hanging out by themselves. So 12 is going to be naked by itself. Great. It's looking a little bit more legit, right? Well, what do I do now? Because I have 2 b's. But here's the thing. These b's are on one side of that equal sign. They're hanging out next to each other. That means I can combine them. So it gives me 48 equals 4 minus 16 is -12. B. I'm going to bring down this 12 right here. Great. So that's just cleaned up, basically. I mean, it's looking pretty like easy now. I have 1b and then I have a bunch of constants. So I just gotta throw everything over on the other side and just get that b by itself. How do I do that? Well, I'm gonna do a plus 12 right here. Let me see. You know what? Oh no. Guys, I'm sorry I messed up. Just a little bit, just a tiny bit. Okay. Here's what's up. Guys, do you see how this is -4 up here? When I distribute it, what I'm supposed to do is -4 times 3. Y'all, it's plus 12. Oh, embarrassing. Okay, sweet. So, okay. Whoopsie diddles. Okay, cool, sweet. So that's what that looks like. So what I'm going to do is I'm going to do -12 and -12 here, right? Okay, cool, sweet. Okay, what does that give me? -12, right? Okay, everything's looking legit, I hope. Okay, so 48 minus 12 gives me 36 equals, I'm bringing down that equal sign, -12b, and I'm gonna leave that 0 out. We don't need it. Sweet. Look how great this looks. So now I need to get b totally by itself. So I'm gonna do -12, -12. When you're dividing, you can keep this the sign as it is. You don't need to flip it. Well, you're not supposed to flip it, rather, right? So 36 divided by 12, 12 goes into 36 3 times. So it's going to be 3 times, but we got to keep that negative b, right? That is our final answer. Hooray, we got it right. We got through it, guys. It was kind of tough, but we got through it. But is it the final answer? What if I'm wrong? I don't know. Let me test it out. This is where it gets tricky. Let's try to test it out. I think what I'm going to do is, let me get rid of this right here. I'm going to rewrite some of the parentheses into a different bracket. So let me actually get rid of a lot of this because I'm kind of having a hard time seeing. So we have 48 equals 4, let's do -3, minus 4. I'm going to do a bracket. And then it's a 4, -3. Oof, this is tough. 3. Yeah, cool. So that's all together. I guess we didn't need that. Okay, let's do that. I think that's legit. Okay. I'm just changing this guy out to a bracket, right? Just so we know that those go together. Because with PIMDOS, we got to make sure everything's legit. So, yeah, we got to set it up correctly. Okay, perfect. Let's go ahead and go through it. So we have 48 here. -3 times 4, that gives me 12. Minus 4. And then we have 4 times -3 gives us -12. I'm going to bring down that 3, right? Do you see how it's getting cleaned up? Let's do it again. I have 48, 12 minus 4, which -12 minus 3, that gives me -15, I believe. Let me check on my calculator. 12 minus 3. Yeah, it gives me -15. Sweet. Okay. Perfect. And then we're going to multiply these guys together. Let's do that next. So I have 48 equals -12. -4 times 15 is it's -60. I put that into my calculator because I'm running out of steam here, guys. Okay, great. And then -12 minus 60 is 48. I'm going to bring this 48 down. Awesome. Awesome, sawsome, possum, something. All right, sweet. Look, we got it. We got it, guys. Hooray. All right. Right. These are kind of tough, y'all. I'm not gonna lie. Okay. Let's do one more. Right? And then I think this is the last one. Yeah, I believe it's the last one. All right, cool, sweet. So this is pretty intense. Okay. We're gonna get through this, guys. We're almost done. This is a long video. I'm not even sure who's watching this anymore. Okay, cool, sweet. So we're gonna do PIMDOS again. PIMDOS. I hope I spelled that right. Okay. We're gonna put that 7 in here, that's 7 in here, that's 6 and 6. And guys, it's positive. So we don't gotta worry about signage for a minute. So let's go ahead and do that right now. So we're gonna do -4n minus 5 plus n equals, that's 49, right? 7 times 7 is 49. Minus 49n plus 1 times 6 is 6 plus, is that 36? Yeah, 36. 6 times 6 is 36. 36n. Cool. Okay, great. Awesome. Looking good. So we have a lot of letter N's. So what's the rule? Okay, so can I grab another pen? Okay. I have an N here, an N here. Oh, wait. Here. Here. And here. Right? So what's up is this is my equal sign right here. Do you see how the N's are on one side and then we have two N's on the other side? Like these are together and then like these are together? Okay, that means we can combine those. So let's see. -4 plus +1 is -3n. I got rid of those. And let's just put that 5 down here. So I'm done with this left side. Let's do an equal sign here. And then negative 49. Let me do this. Negative 49. What is it? Plus 36? Yeah, cool. I got negative 13? Yeah, I got negative 13. N. Okay, let's get rid of those. And then 49, and then 6, that's 55. Right, and I put these two together, and it gave me 55. Cool, perfect. 5, 13, 55. All right, sweet, looking good. I hope this is correct. Okay, great. So, okay, it's looking a little bit more traditional, right? That we've been doing earlier, where we just got to get all the alphabets together and all the constants, like the numbers that are naked, hanging out by themselves. So how do I do that? Which way do I want to go? Let's do positive 3n here and positive 3n here. I think it's easier to subtract the 3's than it would be to do the 13's. Let's see. Let's make a nice little 3 here. Positive. Okay, great. Let's see. That gives me a 0. And that gives me negative 10n. That goes away. So then I have negative 5 left equals negative 10n plus 55. Okay, sweet. Now I just have to get 55 to the other side because I got to get n by itself. That's a 0. That's negative 60. Oof, just kind of going in a direction here. Running out of room. Oh no, let's keep him away over here next to our puppy dog. So we have negative 60 equals 10n, right? Because we got rid of that. All we had left is this and our equal sign. That's why I brought all that over and nothing else. I got to get n by itself. So I'm going to do negative 10 here. I'm going to do negative 10 here. That gives me an n. 2 negatives make a positive, so I know my final answer, if my final answer is correct, is going to be positive. 10 goes into 60 6 times. So my final answer, in theory, should be n equals 6, right? That's what I'm betting on, right? I'm hoping I'm right. So now we have to test it. I'm tempted to not test it and just like end the video here, but let's go ahead and test it. I'm not even sure if, okay, look, I'm going to have to erase some of this. Okay. I'm going to use let's use a different pen just for funsies' sake. Okay, so I have negative 4. I'm going to start over here. And then I'm going to do a little gap here where my guy will go. 5 plus gap 7. Let's do brackets. 7 minus 7 plus 6. 1 plus 6. And that's going to be blank space. Cool. 6 goes in here. 6 goes in here. It goes in here and in here. And I got the 6 from my answer up here. Let's see. Negative 24 minus 5 plus 6 equals 7. I'm going to get my calculator out because I don't think I'm able to handle it anymore. That's 36, right? 6 times 6 is 36. Yeah. Okay, cool. Do you see I'm kind of like adding? I added these together. I multiplied these together, multiplied these together, multiplied these together. And yeah, I think that's all I did. I don't see me doing anything else. Okay. Cool. Let's keep going. 24. 6. Okay, I'm getting 23 here. Let me move it down a little bit. 23. 7. This is going to be negative 35 plus 6. 37. 37. Okay. Plus 1 is 37. Great. And then let me get a calculator again. 7. I have negative 23 equals negative 245 plus, this is going to be 222, according to my calculator. And then I have negative 23, and then negative 245 plus 222 gives me negative 23. Oh my God, guys, we got it right. How exciting. I would have cried if I had to redo that. Sometimes I cry when I do math problems. All right, sweet. It looks like we balanced it. Therefore, our answer is legit. It is positive 6. So when we solve for n equals positive 6. That's the answer you would put on your paper and submit to your instructor. And PIMDOS helped us out. Our puppy dog was here the whole time. Okay, cool, sweet. All right, I hope this video helped. Guys, I got stickers. I sell stickers if anybody wants one. Okay. Okay, thank you, everybody. Bye.